Hello everyone, welcome to this course on Virtual Cloud Network. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this particular module, we are going to look into Oracle Cloud Infrastructure Virtual Cloud Network Service. We are going to look into various components of the VCN service, including subnets, route tables, security list, private IPs, public IP, and virtual network interface cards. We are also going to look into various OCI connectivity options, the various gateways we support. Now this is a level 100 course, and we also have a level 200 course on virtual cloud network where we dive deeper into more advanced concepts. As per our documentation, a virtual cloud network is a private network that you set up in the Oracle data centers with firewall rules and specific types of communication gateways that you can choose to use. A VCN covers a single contiguous IPv4 CIDR block of your choice, and a VCN resides within a single region but can span multiple availability domains. Now before we go into VCN and we look into its various components, it's very important to understand the basics of CIDR. CIDR stands for classless interdomain routing, and it's a very commonly used notation. Now in case of CIDR notation, you would specify a network and host in something like this, where you have 4 octets. Each of these is an octet, so has 8 bits each. So your IPv4 would have 32 bits, and you would say a slash and a number here. This number n is the number of bits which are used for subnet mask. So if you say /24, that would mean 255.255.255.0. Now how did we come up with that calculation? Now let's look at some of the basics, how you describe an IP value, IPv4 value in terms of decimal values and binary values. So something like an IP range like 192.168.1.0/24 would equate to this particular IPv4 range, 192.168.1.0, going all the way to 192.168.1.255. So let's look at how that is constructed. Now as you know, each of these is an octet, meaning it has 8 bits, and the bits are placed like this, starting with from the first position going till the 8th position. So you have 2 to the power 0, 2 to the power 1, 2 to the power 2, or going all the way to 2 to the power 7. And if you calculate their decimal values, you would have values starting from 1 going to the 2nd position, the 4th, the 8th, at the 8th place, the 16th place, 32th place, 64th place, and 128th place. So if you have to write something like 192 in a binary format, to get to 192 you need to add the 128th place and the 64th place, and if you add them together you get 192. So those 2 bits would be 1 in case of binary, and all the other bits would be 0, right? That's just the basics of how IPv4 addresses are constructed. Now continuing the same logic, if we go with the same logic, if we have to write this whole IP value here, it would be donated, it would be constructed around something like which is shown here on the screen. Now earlier we said that /24 would equate to this kind of subnet mask. Now how did we come up with that? /24 means that we have 24 bits which have a value of 1, and if you count the number of ones, that is how we come up with /24. So if you look at this subnet mask here, and if you see all the ones here, we have ones going all the way for these 3 octets here, and then the remaining values are all 0, right? So that's how we come up with /24. 24 is nothing but the number of bits which are turned on and have a value of 1. Now to get to the range, what we do is we do a logical AND, and the logical AND says that if the 2 values you are doing a logical AND on are 1, then you get a 1, every other combination is actually gives you a 0. So just look here. So 1 and 1, I get a value of 1 here. 1 and 1 for the second bits here, I get a value of 1. Now for other values like here, 0 and 1 gives me a 0. Let me see if there is another combination, and so on and so forth, right? So if we follow that logic, we get this value here, and that value is nothing but this particular address range. So if we specify 192.168.1.0/24, this is the IP range we have to work with. Now this is a very simple example, and it starts getting more complex when you have a different subnet mask here, more complex subnet mask, I would say. So what happens in case of /27? So if we go with the same logic as we had earlier, if you do /27, basically you have 3 more bits which are 1, right? Because 24 was all the way till here, and then we add 3 more bits. So 24 plus 3, and then we get 27, right? Now if we do the same logical AND as we did earlier, we get these values here as we had done earlier. Now these 3 bits are 1, but remember we said logical AND means that the 2 entities you are doing AND on both have to be a 1, otherwise it's a 0, right? So 1 and 0 and 1 here is a 0, same thing here, 0 and 0. So this would equate again to this particular IP value here, right? But there is a difference here now. The difference here is, look at these 3 bits which are color coded in blue. What those 3 bits means is we are borrowing those 3 bits for my network. So I basically I have those bits which are used for my networks and my subnet. And these 3 bits, if we do a calculation here, 2 into 2 into 2, it gives me 8 different subnets. The remaining bits can be used for the hosts. So I have 5 bits remaining here. So if I do the math again, 2 into 2 into 2 into 2 5 times, I get 32. So what this means now is I took this big network, and because of this subnet mask, I have divided it into smaller networks, and each of these networks have 32 hosts now instead of the 254 hosts we had earlier. They have 32 hosts each, and we have 8 more networks. So you can see my subnets would be something like 192.168.1.0/27, and you keep adding 32 to this number. So the next network would be /32, the next network would be /64, the next network would be /96, and so on and so forth. Now also remember that if you have a network range like this, the first value here is for the network, and the last value is for the broadcast. So you don't use those two IP addresses. So your host can go from .1 all the way to .254. This is just the basics of CIDR, something which is important to understand as you go and work with the VCN service. Now the rule of thumb is, when you choose your IP address range, avoid IP ranges that overlap with other on-premises or other cloud networks. And as you get into more advanced discussions, you will realize why that is the case and why it is important before you begin to do anything with VCN. You should choose your IP range carefully. So we talked about the IP ranges being specified in this particular format, the CIDR format. Now this value here is perfect because this is the recommended RFC 1918 range, and so we recommend that you use a private IP address range specified in RFC 1918. So these are the values: 10.0.0.0/8, 172.16/12, and 192.168/16. These are the values we recommend. You could use another range outside this, but if you use a publicly routable range, it doesn't mean that your VCN will be publicly routable. It's still private, but you could use, if you have a really old publicly routable range, you could use that, but the guidance is always to use these ranges here. Now we also recommend the size for the OCI VCN service supports all the way going from /16 to 30. As you know, as this subnet mask number increases, the network size decreases. So the biggest network we support is /16, and the smallest network is /30. Now, even though some of these ranges go from /8, just keep in mind that you cannot create a VCN a network within OCI with a /8 range. The biggest we support is /16. And also keep in mind that VCN reserves the first 2 IP addresses and the last one in each of the subnets CIDR. Last slide we saw that the first IP address and the last IP address are anyways not usable even in your on-prem context, but in case of VCN there is an additional IP address in the beginning which is reserved for our own purposes. So keep in mind that those 3 IP addresses are reserved and you cannot use them. Now let's look into some of the more details of a VCN service. So as we have seen in the previous modules on the previous courses, Oracle Cloud Data Center region is comprised of 3 availability domains. Now for the sake of keeping this more organized, I am only showing you 2 availability domains, but every region for OCI has 3 availability domains. So the first thing we do is we create a VCN, and like I said, VCN is a regional service, so it spans multiple ADs. So if there is AD 3 here, which I'm not showing, it actually spans all the 3 ADs. How you create a VCN? Very simply, you just specify the CIDR range, in this case 10.0.0.0/16, and there you go, you have a VCN. Now for the practical purposes, a VCN is subdivided into subnets. Like a VCN, each subnet has a contiguous range of IPv4 values described in CIDR notations. Just keep in mind that subnet IP ranges cannot overlap. So I create 2 subnets here, 10.0.1.0/24 and 10.0.2.0/24, and I name them subnet A and subnet B, non-overlapping IP ranges. Now the reason we create a subnet is to place compute instances inside the subnets. So we put compute instances here. These can be bare metal machines, these can be DB systems, these can be file systems, this can be virtual machines, whatever you want to do here. The idea is instances are placed within subnets. Now these instances draw their internal IP address and network configuration from the subnet in which they are placed. Now that becomes interesting because now you can start to designate subnets as either private, where instances contain only private IP addresses. There is no public IP address assigned to the instances. So you can see here subnet A is a private subnet, or we could designate a subnet as a public subnet. You can see that subnet B is a public subnet. In this case, this particular instance here has both a private IP as well as a public IP. One thing to keep in mind is that subnet is contained within an AD. So subnet is AD specific. We looked into this into this concept in the previous course. Some resources are AD specific, some are global, and some are regional. A VCN is a regional construct resource, but a subnet is specific to an AD. So a subnet is contained within a single AD. Now, so we looked into a private subnet, we looked into a public subnet. So for the sake of this slide here, let's assume that we have a public subnet. So we said subnet B is a public subnet. So what does that really mean? So we place an instance in that public subnet, and the instance has a public IP. We talked about this in the previous slide. Instance has a public IP in addition to a private IP. Now, of course, if the instance has a public IP and it's placed in a public subnet, we want it to communicate externally to the internet. So what we do is we create this resource called an internet gateway, which provides a path for network traffic between the VCN and the internet. So we create this internet gateway here, and what it does is gives access, bidirectional access, to the instance, so it can send traffic out as well as it can receive connections from the internet. There are some things to keep in mind, design considerations. You can only have one internet gateway for a VCN, and after creating an internet gateway, you must add a route for the gateway in the VCN's route table to enable traffic flow. So what is this thing called route table? So this is the same example as the previous slide. We have a public subnet, we have an instance with a public IP, we have an internet gateway. It's sending traffic bidirectionally to the internet, sending out and also receiving connections. But now there is one more resource which has been added here, this thing called a route table. The primary purpose of a route table is to send traffic out of the VCN. A route table consists of a set of route rules. Each rule specifies two things: destination CIDR block and a route target, which also sometimes is specified as called as the next hop for the traffic that matches this particular CIDR block. So let's look into what that means. So the table is constructed something like this. So you have a destination CIDR and you have a route target. So in this case, my destination CIDR is 0.0.0.0/0, which means all IP addresses on the internet. And my route target is an internet gateway. So what I'm telling through my route table is send all the packets through this internet gateway out to the internet. And that's basically what we want, because we looked into what an internet gateway is on the previous slide. Now, a few things, design considerations to keep in mind. Each subnet uses a single route table. As you can see here, subnet has a single route table. You specify the route table at the time of subnet creation, but later on you can edit it. Earlier you could not change it, but now you can, later on you can go and you can change it. You can add another route table. You could edit it. You can make all the changes. Route table is used only if the destination IP address is not within the VCN CIDR block. This is an important concept to keep in mind. No route rules are required in order to enable traffic within the VCN itself. So what that means is, if you have a route table like this, there is no need for a route which says something like 10.0.0.0/16 with a route target as local meaning within the VCN. You don't really need that rule, because route table in our context is only used for sending the traffic if the destination IP address is not within the VCN's CIDR block, this particular block. When you add all kind of gateways, internet gateways, NAT gateways, service gateways, dynamic routing gateways, peering, we'll look into these 5 or 6 different kind of gateways you can create. You must update the route table for any subnet that uses these gateways or connections. So just keep in mind, very important, as you are adding gateways, you need to update the route tables accordingly. So let's look into these 5 or 6 different kind of gateways. So the first thing we start with is a NAT gateway. Same scenario as earlier, but now let's say that instead of a public subnet, we have a private subnet here. So if we have a private subnet, we looked into this on the 3rd or 4th slide, this instance only has a private IP. It doesn't have a public IP. But in case of a NAT gateway, you still want to go and access to the internet. Now you want to do that, but you don't want to assign your host a public IP address. So a NAT gateway gives an entire private network access to the internet without assigning each host a public IP address. So hosts can initiate outbound connections to the internet and receive responses, but cannot receive inbound connections initiated from the internet. So it can go all the way here and it can receive connections, receive responses, but it cannot receive inbound connections which are initiated all the way from internet. Those are blocked. To do those, if you want to do that scenario, enable that scenario, go with internet gateways. Now the use case here is for scenarios where you want to get updates from the internet, or you want to get patches from the internet. So this can be a database which is running here, and let's say for example this is a MySQL database, but it needs to go to the web in order to download the updates and the patches, right? So you would, instead of opening it up to the web using an internet gateway, what you would do is you would keep this in a private subnet, not assign a public IP, just have a private IP, and then make it go to the web and get the patches using a NAT gateway. And as we saw in the previous slide, when you do that, you have to update the route table. So in this case, you are saying the destination is everywhere on the web, but now my traffic is going through my NAT gateway, which makes sense because this is the gateway which is controlling the outbound connectivity. Unlike an internet gateway, you can have more than one NAT gateway on a VCN, though keep in mind that a given subnet can route traffic to only a single NAT gateway. Even if you have multiple, subnet can route traffic to only to a single NAT gateway. If we continue with the previous example, let's say we still have a private subnet and we have a database here. Earlier we had a compute instance. Let's say we have a database here, but we want it to access specific public OCI services such as object storage. As we will discuss in the future courses, object storage has a public endpoint. So let's say if this database wanted to access a public OCI service such as object storage, but didn't want to use an internet or gateway or a NAT gateway, one option to use is called service gateway. So as you can see here, there is object storage which has a public endpoint, but to make this database reach the object storage, you could use something called a service gateway. So what does that mean? What it means is any traffic from the VCN that is designated to a supported OCI public service such as object storage uses the instance's private IP address for routing, travels over OCI network fabric, and never traverses the internet. So in this case, even though this object storage has a public endpoint, it is still contained within the Oracle region. It's part of our service. So the traffic in this case goes over our backbone, our own network fabric, never has to traverse the internet. And the use case here would be something like if you want to back up these databases, one of the places you would use for backup is object storage, because that's unlimited storage, it's well suited for scenarios such as backup. So to use that kind of a scenario, you don't have to use a NAT gateway or an internet gateway, but just use service gateway, and you can reach object storage. So today the only public OCI service which is supported here is object storage, but in future we are planning to add more services here. And as we saw earlier, if you do this, now you have to update the route table, and in this case, instead of a destination CIDR, we have a destination service now, and the destination service says object storage service, and the route target in this case is the service gateway, because you're sending traffic all the way through the service gateway. So we looked into internet gateway, we looked into NAT gateway, and we looked into service gateway. The fourth kind of gateway we have in OCI is called dynamic routing gateway. So the same scenario as the previous 3 slides, we still have a private subnet, we have a database here or a compute instance, but now we have a customer data center. So this is your on-prem existing data center, might be your colo, might be your own on-premises network, data center, doesn't really matter. So we have this thing called a DRG now. A DRG is a virtual router that provides a path for private traffic between the VCN and destinations other than the internet. So just by virtue that it's not going to the internet, you're not using NAT gateway, internet gateway, or service gateway. You can use it to establish a connection with your on-prem network. And there are 2 options you could use. You could either use a IPsec VPN, virtual private network, or you could use a dedicated private connectivity. In case of Oracle, it's called Fast Connect. So you could use those 2 options. And as you can see here, this particular gateway is used to carry the traffic to your on-prem environment on all the destinations other than the internet. Now, when you create a DRG, you must add a route as we have been seeing for the other gateways to enable traffic flow. So same thing as earlier. Now you have a route table here. You have traffic, all the traffic going outside the VCN, and you specify my route target as the DRG. In some cases, you might have a private if your your network here, so this might get replaced with your own on-premises network. So it could be something like this IP, and you could send traffic to that particular destination. DRG is, remember that DRG is a standalone object. You must attach it to a VCN, and VCN and DRG have a one-to-one relationship, meaning a VCN can only have one DRG, and a DRG can only be attached to one VCN at a time. Okay, so we looked into the 4 different kinds of gateways. Let's look into peering now. So there are 2 kinds of peering which are possible in OCI today. So one is peering, for example, is the process of connecting multiple VCNs, and you can imagine scenarios where you have where you need various VCNs for isolation, for security, for management, but you still want instances within those VCNs to communicate with each other. So there are 2 options which are available today. There is something called local peering and remote peering. Local peering, VCN peering, is the process of connecting 2 VCNs in the same region. So keep in mind, it's the same region, and the resources can communicate using private IP addresses. So I have 2 VCNs here. VCN 1 is 10.0.0/16 and VCN 2 is 192.168.0.0/16. Now, for these 2 VCNs to communicate with each other using local peering, you have to do a couple of things. You have to set up something called a local peering gateway, which you set up on your VCN for routing traffic to a locally peered VCN. So as you can see here, we created this local peering gateway 1 on this VCN. We created a local peering gateway 2 on the other VCN. And as we have been talking, we have to update the route table. So in this case, the route table says that I am sending traffic to this particular VCN. So you see this value here, but I'm sending the traffic through LPG1. So this is where the traffic is going. And similarly for the other VCN, the route table says that my destination is this particular VCN, and I'm sending the traffic through my LPG2. This is how the traffic is going. So this is how a local peering works. And the thing to keep in mind, the 2 VCNs in the peering relationship cannot have overlapping CIDRs, otherwise it doesn't work. So similar to a local peering, there's another scenario where you have 2 VCNs, but they are in different regions. Now you could do this for disaster recovery, for example, right? So you can run a complete stack in a region, and you can have the same stack running in a different region, and for DR purposes, let's say you are taking a backup once every day, for example, right? So the second VCN and the second region becomes your DR site. So remote VCN peering is the process of connecting 2 VCNs in different regions. So local peering is same region, remote peering is different region. So similar to the previous scenario, now we have 2 VCNs, same 2 VCNs, but now they have in different regions. So this is Ashburn and this is Phoenix. Let's say the 2 regions generally available in North America today. So in case of a remote peering, things are a little bit different. It requires a remote peering connection. There's something called an RPC, and you have to create this RPC on the DRG, the dynamic routing gateways. We saw earlier that dynamic routing gateway was used to route traffic to destinations outside the internet, to your on-prem environment. But in this case, it's an exception where you also are using the dynamic routing gateway to reach the other OCI region. So we create the 2 DRGs here, and we create something called an RPC, remote peering connection, on those 2 DRGs. And the thing here, what we are trying to do is we are sending the traffic through the Oracle backbone. So the traffic is going through the Oracle network, and it's not traversing the internet. And similar to the previous slide, you have to update the route table. So in this case, you are saying my destination is this particular VCN, and for the other route table, you are saying my destination is this particular VCN, and you are sending the traffics in the first case through the DRG1 here, and in this case you are sending the traffic through DRG2 to this DRG. So similar concept, but implemented in a little bit different manner using DRGs. Now this is generally available for these combinations if you're sending traffic between Ashburn and Phoenix, or you're sending traffic between London and Frankfurt in Europe. It's generally available. If you have a different combination where you want to send traffic from Ashburn to let's say London, you can contact Oracle support and we enable those scenarios. And similar to local peering, the two VCNs cannot have overlapping CIDR blocks. So let's just summarize all the network connectivity options we saw earlier. If you have instances, want instances to connect to the internet and receive connections from it, you go with Internet Gateway. If you want instances to reach the internet but not receive connections from it, so outside parties cannot initiate connections to your instances because they don't have public IP address to begin with, you can use something called a NAT Gateway. If you want your VCN host privately connect to public OCI services such as object storage, completely bypassing the internet, you could use Service Gateway. If you want your instances, your network to extend to on-prem networks, so for destinations outside the internet, you could use a virtual private network, IPsec VPN, which is supported by us, or you could use private dedicated connectivity called Fast Connect. If you want to privately connect two VCNs in the same region, go with Local Peering Gateway. If you want to privately connect two VCNs in different regions, go with Remote Peering Connection, which is a connection you create on the Dynamic Routing Gateway. So these are the 6 most common scenarios you would use for network connectivity. There is one more scenario which we cover in our advanced course, but for because it's a level 100 course, so these are the basics you need to know in order to design your networks. Now let's change gears. Until now we looked into routing and we looked into all the different OCI connectivity options and the various gateways which are available to you. Now let's look into a completely different topic, which is security list. So similar to the scenario we have been seeing earlier, we have a VCN here, we have a private subnet, we have a public subnet, and you have instances within those two subnets. A security list is a common set of firewall rules associated with a subnet and applied to all instances launched inside the subnet. So as you can see here, we have a security list and we have a security list here associated with the subnets. The job of a security list is to provide ingress, meaning incoming, and egress, meaning outgoing rules that specify the types of traffic allowed in and out of the instances. Now keep in mind that security lists apply to a given instance, whether it's talking with another instance in the VCN or a host outside the VCN. So even if this instance is talking to this instance, the security list still comes into picture, or if this instance is talking somewhere outside here, security list still comes into picture. In OCI, you can choose whether a given rule is stateful or stateless. So let's look into what that means. Stateful, there is a term which is used called connection tracking. So what it means is when an instance receives traffic matching the stateful ingress rule, the response is tracked and automatically allowed, regardless of any egress rule, and vice versa. Now what does it mean, right? So let's say we have an instance running here, and this is a host. It can be anything. It can be my phone, it can be a laptop, it can be a server sending traffic. So if this host is sending traffic to designated to port 80, so this can be a web server. So the way it would work is you would write a rule saying my traffic can come from anywhere. Protocol is TCP. My source port can be anything, it doesn't matter, but my destination port is 80. There's the HTTP port. Now if that is the case and you have specified this as a stateful security rule, you don't need an egress rule. the response is automatically tracked and allowed here, as you can see with this dotted line. You don't need to specify a rule here. Default security rules are stateful. So as you can see here in the console, we specify the security rules like this. So we say what is the source type, in this case a CIDR, range, all the values on everywhere on the web. I'm using TCP protocol. Source port can be anything, but my destination port is 80. And before this, you specify whether it's stateful or stateless. So what it means is, if you have a host here, if you have a compute instance running here, they are reachable from the internet on port 80. This is the port. This is basically all the IP addresses on the internet. Now, conversely, you have something called a stateless security rule. In stateless security rule, response traffic is not automatically tracked, automatically allowed. To allow the response traffic for a stateless ingress rule, you must create a corresponding stateless egress rule. So the same scenario as earlier, everything here is the same. You are sending traffic here, destination port 80. Earlier we saw that this traffic was automatically allowed, but now because this is stateless, you have to specifically write a rule here, and the rule says that my destination is everywhere, protocol is TCP, but my source port now is 80. So this becomes my source. Earlier this was my destination, and my destination port is all. It can go anywhere on here on the web. So you could choose to make a rule stateful or stateless, but when you do stateless, you are indicating that you do not want to use connection tracking for any traffic that matches that rule. And you would have guessed by now that these are better for scenarios with large number of connections, because you really don't have to track connections. So think about load balancing, think about big data analytics workloads. It's always good to go with stateless rather than stateful security rules. Keep in mind that there are certain VCN components which are default, which come with when you create a VCN, these are present. So by default, you get a route table. We have looked into what this route table is. You get a security list, which we looked into the previous few slides, and you also get a default set of DHCP options. Now you cannot delete these default components. However, you can change their content. You can change, for example, individual route rules. You could change them, and you can create more of each kind of component in your cloud network. So you could create an additional route table. By rule of thumb, it's a good idea. Best practice is to not touch the default components. Just leave them and create your own route tables and your own security list. But you could choose to use them, and you could change their content as well. Okay, so we covered a lot of ground here. We looked into route tables and the various routing mechanisms, connectivity options, and then we looked into the firewalls with security rules. Let's review these in a practical scenario. So subnets can have one route table. We talked about this, but they can have multiple security lists, up to 5 security lists associated to it. Route table defines what can be routed outside the VCN. Remember, you don't need a route rule to route traffic within the VCN. Private subnets are recommended to have individual route tables. We looked into this earlier, and I said that we have your own route tables. You have the default components, but if you have subnets, private or public, good practice to have their own individual route tables, particularly for private subnets. All hosts within a VCN can route to all the hosts in the VCN. Other hosts in a VCN. No route table is required. We just discussed this. There is no local kind of a route rule required. Security list manage connectivity north-south, so it means incoming, outgoing VCN traffic, as well as east-west, which means internal VCN traffic between multiple subnets. We will look into this on the next slide. OCI follows a whitelist model. You must manually specify whitelisted traffic flows. By default, things are locked down. What it means is instances cannot communicate with other instances even in the same subnet until you permit them to. So that's basically things are locked down. That's basically what I mean by things are locked down. it has to follow a whitelist model. So let's look into what this means. So we have, as we have been seeing, we have our OCI region here. Now, even to make it simpler, I just have one availability domain. It has two more availability domains, but I'm not showing them here. So I have two subnets. I have a front end here, 10.0.1.0/24, and I have a backend, 10.0.2.0/24. So two subnets within a VCN. And as you could guess, my first subnet has a web server, so it is public, and my other subnet has a database backend, so it's a private subnet. Now, as we saw earlier, this one, the front end, the public subnet, has its own route table and its own security list. The backend subnet, and so the front end subnet, we call the route table as front end route table, front end security list, and similar to the front end subnet, the backend one has its own route table and its own security list. Now, by the very nature, because it's a front end, let's say it's a web server, it's initiating connections in and out of the web to the internet. So what would we use there? We would use an internet gateway, right? Simple, we discussed this earlier. So the traffic is going out, traffic is coming in, route table is managing that traffic, and we are able to reach our web server. Now, the web server also wants to reach my database, because that's the whole point. My records, my, let's say it's a transaction, we are, we're running some kind of a, transactional processing system. So my web server needs to reach my database server here. Now, there might be multiple layers within here, right? Might be an app tier in there, or might be some complex queuing going on. So I'm keeping it simple, but there might be additional tiers within there, right? But at the same time, I don't want my backend to be accessible through the internet, right? That's a security nightmare. I don't want that. So things are locked down here. You can see the cross, my internet gateway, my internet cannot reach my backend server because I'm running my database there, for example. So how will this work in the context of routing and firewalls? So the first thing we'll do is this front end route table has to be accessible, is sending traffic in and out to the internet. So the rule is very simple. We say all the IP addresses on the web, on the internet, and my route target is internet gateway, right? This is my route target. It's very simple. My firewall here would say that for ingress, incoming, so first of all, I'm doing stateful. So everything is stateful here. You could do stateless, just for sake of keeping it simple. I'm saying stateful, and by default rules are stateful. So I'm saying for ingress, incoming, traffic is coming from all over the internet. Protocol is TCP. Source can be anywhere, doesn't matter. My port is port 80. So I'm getting the traffic from here like this to my port 80. My outgoing traffic now is only going to this particular subnet. So 10.0.2.0/24 is my backend subnet here. So the traffic is only going here, and the traffic is only going on port 1521. So I'm running an Oracle database which is listening on this particular port. So just keep in mind that this is my outgoing traffic, and this traffic here is only going to port 1521. And because it's stateful, I can receive connections responses from there as well. Now for the other subnet, I can do the same thing as the previous one, but now my route can either be a NAT, if suppose I want this to get some patches. It can be service gateway if I want to do backups, or it can be DRG if I want to do on-prem. So again, let me just repeat. If I want to do let's say patching, I could go to NAT. If I'm doing backup, I could go to a service gateway, or if I'm going to on-prem, I could actually go to my DRG. I'm showing any of these here, but I could have those scenarios, right? In this case, I would probably keep it empty because it's not going anywhere out, right? It's just traffic is just staying here, but I could have done that. Similar to the front end security list, for the backend security list, this one here, my incoming traffic is now coming from this CIDR. So as you can see here, this is the CIDR for my front end. So I'm saying that I cannot, everything else is locked down. Only thing which is allowed this whitelisting is 10.0.1.0/24, and my protocol is TCP, port is everywhere, and my destination is 1521. So this is the port where I'm listening, and then I'm locking down the outgoing traffic. I could say send the traffic out, all the traffic, or I could just lock it down. So this is how you would design your networks. It's a very simple scenario where just I have a front end and a back end. You could have more advanced scenarios, but you can see how the route tables behave and how the security lists behave, and why OCI has a whitelisted model. You have to exactly specify which traffic you allow, even within outside the VCN as well as within the VCN between different subnets. Now we didn't talk about the DHCP option, but we have this thing called internal DNS service. So the VCN, the internal or the private domain name system DNS, enables instances to use host names instead of IP addresses, private IP addresses, to talk to each other. So there are two options which are available. There's one thing called Internet and VCN Resolver, which is the default choice for the new VCN, or there is something called a custom resolver. So if you have instances if you want to use your on-prem network, you could let instances resolve the host name of hosts in your on-prem network using custom resolver. So you can specify either the default or the custom one. Now when you specify VCN, you can specify a DNS label, and the label goes something like this. When you do a VCN, you could say the VCN DNS label .oraclevcn.com. You cannot change this piece, but you can change this piece here. When you create a subnet, similarly you could have a subnet DNS label, and then this whole thing gets added to that. And similarly, when you instantiate an instance within that subnet, you can specify a DNS label here, and then it goes .subnet DNS .vcn DNS .oraclevcn.com. Couple of things to keep in mind. The instance fully qualified domain name resolves to the instance's private IP address. No automatic in OCI, there is no automatic creation of fully qualified domain name for public IP addresses. So for example, you cannot use SSH using hostname .subnet .vcn DNS label .oraclevcn.com. It's not supported, because the fully qualified domain name you get here is actually resolving to the instance private IP address. There is no FQDN for public IP addresses. So until now we looked into the routing tables, we looked into security list, we also looked into the DHCP options and the internal DNS service. Now let's look into the remaining piece of this course, which is on private IP, public IP, and virtual network interface card. So in very beginning we saw that your subnets can be private or public, and depending on whether it's private or public, instances get different network configurations. So every instance has at least one primary private IP address. It has to have, when you create an instance within a subnet, it gets at least one primary private IP address. Now primary private IP can have an optional public IP address assigned to it. In cases where there is a private subnet, there is no public IP. In cases there is a public subnet, you have private plus public. Every instance has at least two virtual network interface cards. These are virtualized network interface cards, and the first one is called the primary VNIC, and the additional VNICs are called secondary VNICs. Next few slides we will look into what these actually mean. And every virtual network interface card has one primary private IP. So the primary private IP actually goes there, and can have additional private IPs also, which are called secondary private IPs. So it gets a little bit confusing. So just let's a graphic here, visual here helps. So you have an instance. In this case, you have two network interface cards, virtual network interface cards. The first one is called primary. The second one is called secondary. The primary has a primary private IP address, and the secondary also has a primary private IP address. Every NIC, virtual network interface card, has a primary private IP address. Now they can also have secondary private IPs, and they can have an additional 32 or 31 secondary private IP addresses, as you can see here. So what's the use of all these various network interface cards and secondary private IP addresses. Let's look into some of these scenarios. Now, as we discussed, every VM has one primary VNIC which is created at launch and a corresponding Ethernet device on the instance with the IP address configuration of the primary VNIC. So if you see this particular host here, it has a VNIC which is created when you launch the instance. When a secondary VNIC is added, new Ethernet device is added and is recognized by the instance operating system. So we have several examples here. The first example is very simple. You have a server instance and it has a primary VNIC here. This has single network interface card. In case of second virtual machine VM2, it has two virtual network interface cards, and these two actually are in different subnets. So this one is in subnet A and the other virtual network interface card is actually in subnet B. So keep in mind that the same virtual machine can have network interface cards in two different subnets. What is the use case here? The use case is virtual appliance scenarios. So various scenarios where you have firewalling requirements, you could use a scenario like that. In the third case, you have a VM here. It also has two virtual network interface cards, but now these two virtual network interface cards are sitting in completely different VCNs. So there is a VCN1 here and there is a VCN2 here. Now this is a scenario which is used for management purposes. So let's say you have a SaaS provider and they have various customers who have different VCNs. You can still have an IDPS solution or a management solution where you might have multiple network interface cards looking into various VCNs. Either can be for management purposes, can be for security purposes, various other scenarios, but that is supported as well. Now we looked into these things called secondary IP addresses, right? So every VNIC is assigned a primary private IP when it's created. Now every virtual network interface card can also have additional private IPs called secondary private IPs. We looked at you can have a maximum of 31 of these. Secondary private IP is assigned only after the instance is launched. So you cannot create a primary and a secondary when you're creating the instance. Or you could do it when your secondary VNIC is created or attached, and there's a process you follow in order to use a secondary IP address. The use case for secondary private IP is for instance failover. So in this case, let's say you have a virtual machine here, you have a virtual machine here, and your VNICs are in the same subnet, the VNIC one here and the VNIC one here for this VM, same subnet. You can move a secondary private IP from a VNIC on one instance to a VNIC on another instance. So if there's an IP here, you could literally move this IP to this particular instance, and this is useful for cases where if this is, let's say, your NAT instance and this goes down, it becomes a single point of failure. So if you don't want to do that, you can create another NAT instance here. In case of a failover, you could just move the secondary IP here to the other VNIC because they are in the same subnet and your NAT is still up and running. So for cases like those, you could use secondary IP addresses. And there are several other cases where you are running containers, etc. You make use of secondary IP addresses as well. Public IP address is an IPv4 address that is reachable from the internet. It's assigned to a private IP object on the resource. So whether it's an instance or a load balancer, etc., you can assign a public IP address. You can have multiple public IPs across one or more VNICs, as we saw earlier, right? So if you have a primary VNIC here, you can have a primary private IP address. You can have a public IP address here, right? Optional, but you could do that. Similarly, secondary private IP, you could do a public here, and so on and so forth, right? And you can repeat this thing for a primary as well as secondary VNICs. Now, which are the resources which get a public IP address? A public IP address can be assigned to an instance. These are precious resources, so it's not recommended in most cases to assign public IP addresses to an instance. OCI public load balancer gets a public IP address. It's Oracle provided. You cannot choose or you cannot edit this public IP. We give you and you have to use that public IP address. The NAT gateway, because it's going and communicating outside, also gets a public IP. It's Oracle provided. You cannot view, choose, or edit. We don't provide you that public IP value. The DRG gets public IP as well. You have the IPsec tunnels. It's part of when you create a VPN connectivity. Again, you cannot choose or edit these IP addresses. The autonomous data processing and autonomous transaction processing services also get public IP addresses. You cannot view, choose, or edit these values. And then we have a container managed Kubernetes service, which also gets which has a master and worker nodes, and they also get public IP addresses, but you cannot choose or edit here. Now, one thing which is missing here, I think in my slide, is also the internet gateway. Gets an IP address, you cannot view, choose, or edit along with NAT gateway. Now, the public IP, there are two different kinds of public IP addresses. One is called ephemeral and one is called reserved. Now, as the name specifies, ephemeral is temporary and existing only for the lifetime of the instance. Reserved is persistent and existing beyond the lifetime of the instance is assigned to. So you can unassign and then reassign that public IP to another instance. So this can be useful in cases where, if your web server dies, you can move the public IP to another web server and your application is still up and running. You don't have to change anything. Ephemeral IP can only be assigned to primary private IP. So you can only have one per VNIC versus a maximum of 32 for reserved IP, because remember, we can have 31 secondary IPs and one primary private IP, and each of them can have a reserved public IP. There is no charge for using public IP, whether you are using reserved and even if the reserved public IP addresses are unassociated, they are not associated with any running instance. So with that, we covered a lot of ground. Let's look at a quick demo of a virtual cloud network and see its various components. So I'll bring up my console here. This is the console we have been using we saw this in our first course on identity access management, where we went through various services. So if I click here, right now I'm in the Ashburn region, and if I click here, I can see the various OCI services, and I can see a class of services here called networking. So if I click on that, the first link here is virtual cloud network, and when I click on that, it shows me I can create a VCN here, virtual cloud network here. Now there is different compartments available, and for this course we are using a compartment called training. In the previous course, we looked into best practices of compartments, and one of the best practices is to have various compartments depending upon various requirements or the various projects. So we should not put stuff in the root compartment, but have our own individual compartments, either by projects or departments or by different kind of network infrastructure requirements. So in this case, let's just use the training compartment, and first thing I'm going to do is I'm going to click on this create virtual cloud network and create a network here. Now there are two ways to create a network here. One is you provide a name, and then there is a radio button here which says create a default or sort of a test virtual cloud network. It says create a virtual cloud network plus related resources. So it creates a VCN, it gives me a CIDR block, I cannot change that, and it also creates a bunch of other resources. So if I just click on that, I can see that the default virtual cloud network is created for me. And if I click here, I can see that this is the VCN I created, VCN1. And if I click on that VCN1 link, I can first thing I see is this is the CIDR block 10.0.0.0/16. It's created in this training compartment. And right here I can see that there are 3 subnets created, and these subnets are all public, and the service actually chose the CIDR blocks, so 10.0.2.0, 1.0 and 0.0, right? And I can also see that there is a route table, the default route table which is created. It has a rule and the rule basically says that send all the traffic to the internet gateway. So this is pretty much simple scenarios where I have a VCN, 3 subnets. Each of the subnets are in respective ADs. So my first subnet is 81, the second one is 82, and the third one is 83, and then there is a route table which is sending the traffic to the internet gateway. Now if I click on security list, it's a default security list. I can see that I have 3 ingress rules. The first rule is saying that I can SSH into this machine, into this network at port 22, and there are a couple of other rules for ICMP purposes, things like destination unreachable and what kind of response I get if I run into those scenarios. There's also an egress rule which says that egress, all the traffic is allowed for all protocols. It says all traffic for all ports and for all protocols. We'll look into what that means, but just keep in mind that you can always change these rules, but what this egress rule means here is you can send all the traffic is allowed out of my VCN. Now if I go here and I can see other components as well, right? So the different gateways we talked about: internet gateway, dynamic routing gateways, local peering gateways, NAT gateways, service gateways are all available here. Now let's go here and create another network, and this time we'll go step by step. So I would say that the name of this network is VCN2, and now I would just create a virtual cloud network. I am not interested in creating anything else. I would just create a simple virtual cloud network. So we have been seeing this example earlier, even in our slides. I would choose this particular CIDR block, 192.168.1.0/24, and this becomes my network. This is the network I have, and the network is small, 256 IP addresses. I'm okay with that. I can choose a DNS label here if I want to change it, and I can also do things like tagging, etc. So I create this virtual cloud network, and the first thing you would see is the network is created. This is the CIDR block I specified, but it doesn't have anything else. It doesn't have any subnets. It has the default components, of course, the route table, the security list, and the DHCP options. So you can see a value of 1 here, but rest everything else there is no value, because that's how you would go and build your network. So the first thing I need to do is I need to create a subnet. So I would say that this is my public subnet, and I would just say public is fine, and I want to create this in 81, and now it's asking me for a CIDR block 1.0/24. Now I can take that IP address and I can break it down into smaller subnets. So right here, this is the example we saw on our slides. I could choose a CIDR block of 192.168.1.0/27, and you can see that this is the range which is provided here. If I wanted to go to the next range of private subnet, I would go to 32/27, right, and so on and so forth. So for now, I would just use this range, and right here it's asking me to choose a route table. So I will use the default route table, that's perfectly fine, and I would use the default security list. Now if it was I can change these values later on, but I could also create a new route table and a new security list. I could do that. Now right here I can choose public or private. So right here it's saying public subnet, because I want to create this as a public subnet. So I would click create here, and my public subnet is now created. Now one thing I need to do is I can go and create additional subnets, but before that, the thing which I really want to do is, because it's a public subnet, I want to create an instance, and I want to have that instance be accessible from the web, from the internet. So to do that, remember we went through this on the slides, I'll need to create an internet gateway. So I would say create an internet gateway, provide an optional name, click here, and my internet gateway is now created. So I go back to my route table and see right here it has 0 rules. So there are no rules within my internet gateway. So I can click here and I can say edit route rules, and I can add a rule. So the first thing it says is, what is my target type? These are the OCI connectivity options, that various 5 or 6 options we went through. So right here I will choose my internet gateway because I want this to be accessible on the web, and it's asking for a CIDR block. So because I want it to be reachable from all the addresses on the web, I would choose this range, and now I would choose an internet gateway, the one we just created, and I would save this rule here. So now see all the things we have created now is, first thing we did is we created this network VCN2. We created a public subnet in AD1, and we gave this range here, smaller range, 32 IP addresses. We had a default route table. We added a rule here which says send all the traffic to the web using internet gateway, and the internet gateway was not created by default, so we had to go and create that internet gateway. Now I could make it more complex. I could create a private subnet, I could create a NAT gateway, service gateway, all that. We have a level 200 course where we go into more advanced concepts, and we cover those. For now, the last thing I want to do is, my network is all set up. I would go into my compute service and I would create an instance. So right now, as you can see, there is no instance which is created here. So let me go ahead and change that. So I would say I'm creating a web. I have a web server here. Let's call it web 1. It's an AD1. That's fine. I'm using Oracle Linux, not a problem. Virtual machine is okay. I can use a 1 core machine with a 15 gig of memory. That's fine. And I need to choose my SSH keys. So I have SSH keys available here. So I'll just choose that. And now it says which network are you planning to use. So I'm planning to use the VCN2 network we just created, and the subnet is the public subnet we created, right? The only subnet we have is the public subnet. So I'm going to create that, and now I'm going to click on create, and this will create my compute instance, and we should be able to SSH into the instance, because remember, for being able to SSH into the instance, the two things which we require, one is it should be able to have connectivity going outside. So it should be it should have the route rule in the route table. We created that, and then the port 22 must be open in the firewall. So as this is coming up, let me go back to my network. Actually, I can go back to the network. Okay, it's still coming up. So I go back to my network from here, and if I click on VCN2 and click on my security list, remember we are using the default security list. Like I said, we could have created our own security list, completely fine. Right now we are just using the default security list. So if we go here, we can see that by default we have 3 rules which are available. So we have source CIDR, all the IP addresses, protocol TCP, open at port 22. So this is for SSH. I can easily SSH into the instance, and I have 2 other rules for ICMP traffic. I also have an egress rule which says all traffic allowed for all protocol. So I have this created by default. I didn't change anything, and with this I should be able to log into my SSH into my instance. So now this is coming up. It should be up and running within few seconds, and I have git bash running here. As the instance is coming up, you can see some other properties. So you can see that there is a virtual network interface card which got created, and you can see it's the primary VNIC, which we saw this earlier. There's a private IP address. There's a fully qualified domain name. If you click on show here, you can see it goes something like web1.public. You cannot SSH using this, but you could use you can see the FQDN here. You can see the public IP address, so it got a public IP address here. Now I think the instance is still not instantiated. Let me just check. I'm not sure if I'm able to SSH yet or not, but let's give it a shot. Okay, it's up and running. I provide the value, and now you can see that I should be able to SSH into this instance. So it says, do you want to connect to this instance? I say yes, and there you go. I can now come here and I can say I can ping google.com, for example, right? And you can see that I'm able to do that. Last thing on pricing is very simple. You can see there is no fee for incoming data. Outbound data for the first 10 terabyte a month is free. After that, there's a nominal fee, and there's no charge for data transfer between ADs within a region. So to summarize, in this module, we looked into VCN and the core concepts of VCNs, including routing and firewalls, and we looked into some other resources such as private IPs, public IPs, and virtual network interface cards. And then we described the various connectivity options, and we looked into their use cases. Thank you so much for attending this course on virtual cloud network. I hope this was useful, and I look forward to seeing you in the next course on how to connect your on-prem environments to Oracle Cloud Infrastructure.